This is Geometry Unit 11, Lesson 5, the rest of the notes on cylinders and prisms. Okay, so we left off talking about volume, and volume in general is V equals capital B H. Now remember, capital B stands for area of the base. Okay, so you have to know what kind of base you have for your prism and what its area formula is. Okay, so if we're looking at the volume of the prism at right, what kind of prism is this first? Well, it's named by its bases. It's got triangular bases because the faces are rectangles. So this is a triangular prism, so we have to know the volume formula would be the area of the triangle times the height. That's what we're looking at for this one. Okay, so let's look at the area of the triangle. The two bases are triangles, and actually they're isosceles triangles, which are right here. These two bases right here. So we need to know the area of a triangle. So what's the area of a triangle? Well, it's 1/2 base times height. All right, so we know the area of a triangle is 1/2 base times height, and then the height here is the height of the cylinder, or the prism, excuse me. All right, now the prism's height is the distance between the bases. All right, so which value is the distance between the bases? Well, which value is the distance between the two triangles? Well, here's one triangle, here's two triangles. This right here would be the height. So the height is actually going to be 15 right there. Okay, now for the triangle over here, we have 1/2 base times height would be the area of the triangle. Let me do that over here. Okay, so do we know what the base is? Yeah, the base will be 10. Okay, is the height 13? No. Remember, on a prism, or excuse me, on a triangle, the height is measured perpendicular. So the height is actually right there. So let me draw this out over sideways so you can see it. All right, so the triangle looks like this. All right, this is 13, this is 13, and this is 10. So what am I dropping down when I draw this line in? I am drawing an altitude. And what does that create? Well, in an isosceles triangle, when you drop the altitude, it creates two right triangles, does it not? And what does the altitude do to the base? It bisects it. So this is going to be 5, and this is going to be 5. How are we going to find x? Well, isn't that a right triangle? We can use the Pythagorean theorem. The hypotenuse is 13, so this is going to be 5 squared plus x squared equals 13 squared. So 25 plus x squared equals 169. Subtract the 25, you get x squared equals 144, and then take the square root, x is 12. So that means that this height right here is going to be 12. Okay, so now I can do 1/2 times 10 times 12 is going to be my area of my base. So that is going to be 1/2 of 10 is 5 times 12 is 60. So the area of the base is actually going to be 60 times 15. And 60 times 15 is 900. So the volume is going to be 900 cubic units, whatever the units happen to be. Okay, because remember, volume is cubed. All right, so area of the base times the height. You may have to do a little work off to the side. Okay, so the next thing we're going to talk about is going to be surface area. Let me turn the page here. Oops, hit the wrong button. There we go, got the right one now. All right, the surface area of a cylinder consists of two parts. There is the lateral area, which is the area of the lateral faces or base surface. All right, so basically the lateral faces would be the distance between the bases, those rectangles that are made, and the base area is the area of the bases. All right, just what it sounds like. So for a right cylinder only, the lateral surface area is L equals PH. All right, so a right cylinder means it's a perfectly straight up and down cylinder like this. Okay, P is the perimeter of the base, and H is the height measured perpendicular to the base. So when you have the height, you have to go perpendicular to the base. This has to be a right angle going down. All right, so the pool from the earlier problem, from the previous ed puzzle, has a perimeter of 50 feet and a height of 4.5. All right, find the total surface area of one side of the pool liner. Okay, so we figured out previously that the base of the pool down here is 185 for the base. And L equals pH, and then plus the 185 for the base. All right, so if we're trying to do this part right here, the darker blue, all right, so we need to know the perpendicular, or excuse me, the perimeter of the problem. So this is going to be 50, and the height here is the distance from here to here is 4.5, and then plus 185. All right, so 50 times 4.5 is 225 plus 185, and that adds up to be 410 square feet. Area is squared, so it's going to be squared. Okay, so now what if I wanted to find surface area of something? Let me move down to the next problem. All right, surface area of a cardboard box. Okay, now surface area, remember, is defined of the area of all the surfaces added together. How many surfaces does a rectangular box have? Well, it has 6 surfaces, or 6 faces. Okay, now some of them are the same. All right, now let's draw a quick picture of the faces that we have. All right, let's do the front and the back. All right, so let me draw a little picture here. All right, let me undo that. All right, so there's 2 of them that this is the front and back. This is 2.5, and this one is 2. All right, so there's 2 length times width, 2.5 times 2. All right, this is the front and the back. All right, now then we have, I was talking about the front and the back are these 2 right here. That one and the one in the back. Okay, then we have the 2 side ones, this one over here. Let me do a different color of my highlighter so you can tell which one I'm talking about. All right, we're talking about this one right here. There's that one right there. Sorry, my dog is taking a drink. We have 2 of those pink ones, like that. There's 2 of these. This is the sides. It is going to be, the side here is 2, and this is going to be 1.5, and there's 2 of them. So there's 2 1.5 by 2 rectangles for the end. All right, and then we have the top and the bottom, and we have 2 of those. Let me outline them here so we can talk about those. The blue ones, this, and the one on the bottom. Okay, so we have 2 of those. Let me draw my rectangle. There's the rectangle there. All right, now, what is the length and width of that? Well, this one, remember, this is a rectangle here, so that means it's this side, opposite sides are congruent, so that's also 2.5. All right, this is top and bottom. And there are 2 of those. All right, so this is 2.5, and that means that this side right here is also going to be 1.5 because it would be the same as this one over here. All right, so this is going to be, I'll put it over here, it's 1.5. So 2 times 2.5 times 1.5. Okay, so let's multiply all these out. 2 times 2.5 is 5 times 2 is 10. 2 times 1.5 is 3 times 2 is 6. And 2 times 2.5 is 5 times 1.5 is 7.5. So when I add those all together, I get 23.5 square feet because area is in square units. Okay, so notice when I did this, I had to make sure that I got all of the sides. Remember, you have to know what kind of faces that you have. Okay, now what if we want to do a surface area of the prism? Well, how many faces does this have? Well, let's see. This triangular prism that we have 2 bases. There's going to be 2 triangles. And how many faces is this going to have? Well, let's see. We have 5 total because we have the 2 triangles, and then we've got these 2 rectangles, this one here, and this one in the back. And then we've also got the one in the bottom. So we have two rectangles that are the same, and then the one on the bottom that is different. So we have two rectangles on the side, and then one rectangle on the bottom. So this is going to be the base, or the one that's on the, it's the face that's attached to the base. All right, so let's figure out our values. All right, now we did previously, we did this one before. This is the same prism that we did before, and we already figured out that the height on this was going to be 12 because we did that previously. Okay, so we already figured out the area of the base on this one. I'll even write it down here again. There's two of them. It's 1/2, base is 10, and the height is 12. So that's going to be 2 times 60, which is going to be 120. Okay, now the two blue rectangles. Let me do the blue ones so you know which ones I'm talking about. There's two blue rectangles. So I have to do length times width for that one. All right, so what's the length and the width for the blue rectangles would be 15 and 13. 2 times 15 times 13. And that comes out to be, take my word for it, is 390. All right. Oops. Plus 390. And then this one purplish rectangle here, the base is, there's only one of them, but it's going to be 10 times, what is this one right here? It would be 15, which is 150. All right, so when I add all three of those together, it comes out to be 640 square feet. So there we go. All right, so that's the surface area of the prism. Okay, last one. We have the lateral surface area of the cylinder. Now, this is a little goofy because we have to think about wrapping this. All right, now what kind of bases does the cylinder have? Well, it has two circles. All right, let me draw two quick circles here. All right, so I have a circle here, and I have the other circle that are the same. So when I draw them, there are two of them. And how do you find the area of a circle? It's pi r squared. There's two of them. Okay, so area here, area here. All right, and then we have this, if you unwrap the circle, it actually looks like this around that. So technically it's a rectangle, but this part of it is going to be the lateral area, is what we have to do. All right, now this is curved, goes around the circle, so this is actually the perimeter of the circle. It's 2 pi r. And then this part is going to be the height, which is going to be 4. All right, because this curves around like this going around, the height side of the rectangle will actually be the side. So this is going to be 2 pi r squared plus 2 pi, r, and then times h. And that would be the surface area of the cylinder. So surface area equals. Okay, so 2 pi r squared would be 2 pi times r squared. R in this case is going to be 4, because that's the radius, plus 2 pi. R is 4, and then h in this case is going to be 12. Okay, now notice when I do this, I'm going to leave this in terms of pi till the very end. So 2 times 4 squared is 16, times 2 is 32. So this is going to be 32 pi, plus 2 times 4 is 8, times 12 is 96 pi. Added together gives me 120 pi. Now, in terms of pi, this would be the surface area. But if we wanted to figure it out, approximately, we'd put this in our calculator in terms of pi. 120 pi is going to be 376.99. So approximately, 128 is supposed to be, I'm sorry, 128. 128 pi, can't add today, is going to be approximately 402.1. So approximately 402.1 square centimeters, because that's that. So if it's not asked in terms of pi, this is exact. If they ask you to round it to where it says. But notice I did not round it until I got to in terms of pi. Okay, so that is the rest of the notes on cylinders and prisms.